Okay, welcome back. Good morning to all. So in the last class we discussed about the classes of certificates and steps for digital certificate creation. So there is about this after this certificate creation, the different features regarding this the digital certificates like security, you can say scalability, and the reliability and authenticity and public trust. So security, these are the main features to convince the digital certificate. And regarding security, digital certificates are the most practical option to securing your corporate data online. Scalability, from small to large business, digital certificates can still provide you with the same quality of encryption. Next, reliability. You might be thinking, where do digital certificates come from? Our institution known as Public Trust Certificates Authorities handle the issues of digital certificates. Authenticity, that means authenticity means where an email or website can be faked, or digital certificates help make sure your message will come across to its intent recipients. Public trust, by ultimately encrypting your company, website and digitally signing your documents and emails. So these are the main features about these digital certificates. Next is your PKIX model. These are the method through which first is your registration process, then initialization, then certification, then key pair recovery. So in PKIX model, first come to the registration process. This is the process whereby user first makes itself known to a CA or certificate authority through an RA, registration authority. So prior to that CA issuing a certificate or certificates for that user, registration begins the process of enrolling in a PKI. Registration usually involves some offline or online procedure for mutual authentication. Next is your initialization. Before a client system can operate securely, it is necessary to install key materials that have the appropriate relationship with keys stored elsewhere in the infrastructure. Next is your certification. This is the process in which a certificate authority issues a certificate for user's public key and returns that certificates to the user's client system and or posts that certificates in repository. Next is your key pair recoveries. Key pairs can be used to support digital signature creation and verification, encryption and decryption, or both. When a key pair is used for encryption or decryption, it is important to provide a mechanism to recover the necessary decryption keys when normal access to the keying material is no longer possible. Next is your end entity. A generic term is used to denote end users, devices, or any other entity that can be identified in the subject field of a public key certificates. End entities typically consume or support PKI related services. Next is your certification authority. The issuer of certificates and usually certificate revocation list, CRLS. It may also support a variety of administrative functions although these are often delegated to one or more registration authorities. Next come to the registration authorities, an optional component that can assume a number of administrative functions from the CA, and the registration authority then is often associated with the end entity registration process. CRL issue, an optional component that CA can delegate to public CRLs. Repository, a generic term used to denote any method for storing certificates and CRLs so that they can be retrieved by end entities. So, PKX so next going to discuss these are the the process of PKX model, and this PKIX model generally is used to the advanced or the enhancements version of the previous one. So this was the PKIX model. Next come to the public key cryptography standard. In the PKCS, we can say it is the PKCS, public key cryptography standard. The PKCS or public key cryptography standards, it stands for Public Key Cryptography Standard, is a model developed by RSA Laboratories in early 1990, designing to standardize the public key infrastructure. Public Key Cryptography Standard provides a total of 15 standards, names as a number like PKCS has 1, PKCS has 2, PKCS has 3, and so on up to PKCS has 50. So first come to the PKCS has 1. The main purpose of this standard is the RSA encryption standard, and this standard defines the basic rules for RSA public key functions, more specifically the digital certificates. So PKCS2, the main purpose of this standard is the RSA encryption standard for message digest, and this standard defines the calculation of message digest. What is the message digest? Now message digest is an encrypted format method, encryption method through which you can store the password in the encrypted mode. Nobody can easily access this password from the database, because the plain text message, or you can say the plain text, it is easy to recognize the ID and the password, but in the message digest method, the password is not easily retrieved the data because it is purely in the encrypted form. Next is your PKCS2. The main purpose of this standard is the RSA encryption standard for message digest, and the standard defines the calculation of message digest. We have already discussed. PKCS3. The main purpose of this standard is the Differ-Hellman key arrangement standard, and this standard defines the mechanism to implement the Differ-Hellman key agreement protocol. So this main standard is the Differ-Hellman key agreement protocol. This PKCS has 3. Next is your PKCS has 4. This public key cryptography standard also emerged with PKCS 1, so it also does not have an independent existence. because it is merged with the PKCS1. PKCS5, the main purpose of this standard is password based and password-based encryption. It identifies the method for encrypting an octet string using a symmetric key which is derived from the password. PKCS6, the main purpose of this standard is the extended certificate syntax standard, and it defines the syntax for extending the attributes of the X.509 digital certificates. PKCS has 7 standard. The main purpose of this standard is the cryptographic message syntax standard. It defines the syntax for the data, which is the resultant form of cryptographic operation. PKCS has 8. The main purpose of this standard is the private key information standard, and it defines the syntax for private key information, or in other words we can say that it defines the algorithms and attributes that are being used to generate the private key. So, and then PKCS has 9. The main purpose of this standard is selected attributes types. It defines the selected attributes types that are used in PKCS. Has 6. It is an extension version of PKCS X. So PKCS 6. Sorry. Next is your PKCS 10. The main purpose of this standard is the certificate request syntax standard. It defines the syntax to request the digital certificates. PKC 11, the main purpose of this standard is the cryptography token interface standard, and this standard is also known for Cryptoc. PKCS has 12. The main purpose of this standard is personal information exchange syntax. It identifies the syntax for personal identification such as digital certificates, private keys, etc. PKCS 3, the main purpose of this standard is the elliptic curve cryptography standard. PKCS was 14. The main purpose of this standard is the pseudo random number generation standard. PKCS 15, the main purpose of this standard is the cryptography token information syntax standard. So these are about all the PKCS model, and remember this model is PKCS model is an enhance of the previous models. So thank you to all. Next class we will discuss, or you are going to start the new chapter number 5. Thank you.